All right. Give me a little context. I have a simple project here with 5 instances. One's acting as a load balancer, and behind it are 4 application servers. I'm sending traffic requests, HTTP, to the load balancer. And what we're able to visualize here is, for this project, the network utilization of each machine. So you can see the load balancer kind of taking the aggregate load, and then you can see each virtual machine is sharing the load behind that load balancer. And then if I drill into a single instance, such as the load balancer, and then I can take a look. Let me refresh this page. Yeah, cursor of the demo here. Okay. It's not showing me the metrics.
Configure the apps.
Oh yeah, sorry. I skipped my step. Yeah, I'm trying to go too quickly. I apologize. Thank you for putting me on course. Okay, so first thing is that, so we saw that network traffic, but we don't necessarily know what it is. And so if we take a look here, what we do is we've discovered the applications that are running in the networks based on what requests are being made to a particular instance. So in this case, we see there's port 80 traffic being sent to this instance. We can, if we know it's HTTP, we can assign an analyzer to it so that we get more in-depth metrics. We'll go ahead and configure that rule. Now that we have configured that application, now I should be able to refresh and go see what I was trying to show you before. So let's, in fact, why don't I configure just a couple more applications there, as we had discovered a few more. So now we're also seeing the application servers here on different instances. If you look closely, the instances are were different than before. So now I can drill into the charts. And if I go to the load balancer, now you can see, since we have discovered applications, some of the metrics I can show. So I can show the application's egress, bit rate, packet rate, response time, and why don't I put the egress rate here. We can see this application, how much it's using. And you could look at, say, the response time. And we can zoom in a little bit there. So now what we can do is say, okay, how is this application server performing? Right? We can look at it and say, you can analyze the response time to understand if there's problems going on. We could set alerts based on this to notify us when an application server is maybe perhaps slowing down or having some kind of problem. And what's interesting also is that on the load balancer, we're looking at kind of both sides, so you can see the response time that the load balancer is seeing average to its application servers, as well as what its response time is in servicing those client requests. So we can also show things like the request rate. So for HTTP, I can look at the response rate or the request rate. I can even look at, I'm going to start a little blip of traffic here. I can look at the error rate. If if you're seeing 400 status codes, we would be able to show that. Just click here, so you could see how often there's errors being. What's the rate at which errors are being served by your applications. And so what else is useful about this information? Now, when we see the network I/O, we can identify contention. So I'm going to start some more traffic here. Yeah, so So I'm actually configuring what we call the I/O control module that allows us to do some quality of service for your applications. I'm going to start some traffic, some different traffic now on a certain instance. So if I go back to the top level view, let me just set up quickly.
Shout out for Born Show, just saying. Born Show.
So what I have now is I'm generating traffic just to a single instance right now, but that instance is shared on a single host and with another instance. And what I'm going to do is I'm going to send traffic to the other instance, and what obviously will happen is that they are going to have to start sharing the physical network I/O capacity. So here, obviously, we see that they start contending for network resources, and the way in which they're competing might not align with the priorities of your applications. So you would want the capability to say, I want to give preference to this application and limit the amount of resources another application is getting. So if I say that the application that's depicted in blue here maybe is higher priority, I might want to limit the green application. Maybe I want to say, okay, I'm going to give that 250 megabits of bandwidth so that the blue can have better performance. And so I'm going to show you sort of some back end of our APIs just to set up this rule, kind of going deep down into how you configure via REST. So if I find the application down here. So vport,
VM definition.
So
No, not from what?
While he's finding it, that's
this one.
that's a listing of all of the API endpoints on our system.
And this is all public.
All public, yeah.
So I'm just going to find a particular instance that I want to limit. I knew that one happened to be running on. I show you here. The green is what I want to limit. It's running on App Server 3, App Server 1. And so I'm going to locate that and then find its identifier so that I can limit the amount of bandwidth that it receives. Let's put.
We're doing this the slow way on purpose, just to. So we're doing this the slow and dirty way on purpose, just to show you the APIs. But in a real system, or even in our system, we have all of this scripted using Python. So you make these calls, you grab these tokens, all of this using.
So, yeah, in me trying to remember all these things, I'm not doing a good job of explaining. So thanks to me. What I've done is I have to have an authentication token, which I use a script to log in with my credentials and use that token for any of the API calls. The second, what I did is I found the ID for the virtual interface on which App Server 1 is sending traffic. So now I'm going to configure the bandwidth, let's say 200 megabits per second. This is expressed in kilobits per second. And once I configure that, then we should see it clamp down. Okay. Sorry, so I forgot one step in configuration, and appreciate your patience while I debugged that. Let me show you now. So
you should just quickly explain what you're going to do.
Right. So we have what I'm going to do is the top line is in blue. I'm actually going to limit that one to 200 megabits per second, and that allows the application in green to utilize the rest of the network capacity that it has demand for. So I'm finding the right entity that I want to configure here. Set to 200 megabits per second. Try that out. And here you'll see now the blue line at the bottom reporting 179, 182. So it's clamping below 200 megabits per second as we requested.
So that's an API-driven infrastructure limiting function.
Yes.
Is that a summary of what you've done? Okay.
Yeah, it works both ways. You can limit access, or you can even guarantee access to something else.
Yeah.
And really the motivation for implementing this is, as we look to the future, more and more applications, more and more services are like built with some kind of like microservices architecture, right? Where you have many components which are distributed all over your infrastructure, and then they need to communicate with each other. Also, these components then kind of go to shared services. So for example, they'll go to a shared storage service, right? Now, using something like this, you can dynamically control the amount of I/O each one, or each one of those gaining access to the shared service. So imagine you currently have 100 containers accessing that shared storage. 10 minutes later, you have 1,000 containers, right? Half an hour later, you're down to 100 containers. What happens and how kind of the I/O capacity gets divided up as these containers scale up and scale down is what this allows you to do.
So because previously we've talked about all the monitoring, this is now the reactive step to that in a very quick way, in a way doing what VMware Resource Pools does, but OpenStack on KVM or QEMU or something like that.
Yeah.
Well, there's quite a difference, because now you're actively, what VMware Resource Pools don't do, now you're actively, how you call it?
Creating a limit, or?
Yeah, creating a limit. But how do you take it off?
Let's do it.
Well,
With an
it's
API
probably
question,
the reverse thing. But how do you decide that you can take it off?
So, and that's what the point was. So, as we took this to customers, initially many of them had their own application orchestrators, right? And their orchestrator knows how many containers are currently running, how many it's going to spin up, how many it's going to scale down to. And while it's doing that, on the fly, it can issue this REST call, and the policy changes on all of the nodes.
So I see this, for example, let's say I am using in-guest agents for my backups, for example, over the VM network.
Yeah.
I can set a schedule, potentially in the future as well, to say, okay, right, at this point in time, over this particular port, it talks over the backup ports, limit my traffic to X or Y, yeah? And then once it's done, this time in case, let it go free again.
Yeah.
Limit backups.
Yeah, ever.
You can make it time-based, but then what it means to the future is that we integrate this with the Kubernetes orchestrator, right? So then as Kubernetes is orchestrating these containers, as those pools grow and shrink, the underlying policy in the infrastructure changes along with it.
But then would Kubernetes be because you've done an API call which is doing the limiting, would Kubernetes do that itself to OpenStack or KVM? Or would it come through your, because obviously it's going to receive the information from your environment, but this is your AppFormix doing the action as well,
right?
Or would Kubernetes do that natively?
So for now it would have to come through us.
Okay.
But maybe in the future we open source more and more of this and it gets integrated.
Okay, so yeah, in fact, to lead on from that, what is your sort of, OpenStack being a very open source community driven thing, what is AppFormix's thoughts on, first of all, open source, and then also the future of where you see this going?
So the future is in analytics and control. The future is not in monitoring, right? We have to do the monitoring to backfill, right? To prove to the user that yes, indeed, we did do some work for them, right? And if there is a problem, then we want to be able to quickly troubleshoot it. So in this case, there was the big gap in the enterprise was operators saying, I want to give all the users in the enterprise access to the information that I have in a kind of like a controlled manner. So that was the primary use case for monitoring. But really, for us as a company, where we are headed is the analytics and the control capability. So potentially we'll open source more and more of the monitoring capability, and spend more and more of our energies on building out the analytics and control.
So that says your sort of plans are being able to give the developers more access and more information on the infrastructure, so they can in fact code into their applications using your API.
Right.
ways that they can consume infrastructure, whether it's adding reservations to their own VMs or limiting network throughput or checking whether containers are going wild or that kind of thing.
Yes.
So the analytics that the infrastructure people have, but literally giving it to applications that can automate that to whatever they think of.
Yes.
Okay.
Right. And that's really what it is, right? It's we want to have the right set of APIs that enables that next layer of innovation. Right? We can't do all the innovation ourselves.
But we mustn't think of it as automation for infrastructure people. It's actually automation for application people who are writing apps to be able to intelligently scale up and down their
It's both.
containers.
It's both.
For applications to make those intelligent decisions, they
Yeah.
actually need to know the context on which they're running. Right?
Yeah.
It's
I
important
suppose
to
my point being
understand those infrastructure
applications
metrics.
knowing that, because there are loads of infrastructure monitoring tools.
Right.
But you guys are doing something that you believe is different because it's application centric, that the
Right.
applications themselves can gather these analytics and then make actions based on whatever
Yeah.
you find.
Yeah, but the absolutely true. But here's what happens, right? I mean, like if we go to our customer, and really our customer in the organization is the operator, the guy who owns the server, not the person who owns the app. Eventually, what we want to do is bridge the gap between the guy who owns the server and the guy who's writing the app. But to get there, we really have to make the server guy happy. So that's why we have all this monitoring.
You always have to make the server.
You always have to make the server guy happy, right? That's why we have all of this monitoring. That's why we have this auto migration, right? That's why we have these alarms and the integration with PagerDuty, right? That's to make the server guy happy, to make his life easier, right? To enable, those large enterprises where there's like literally there's clusters of hundreds of servers being managed by 2 operators now, to make life easy for them, to cut the number of trouble tickets that are in the enterprise, to cut the number of phone calls they're getting, right? Enabling that self-service. But really, what the community that we really want to enable is the app developers. And that's where all of these APIs come in, right? They are now able to see, hey, this is how my application is running on the infrastructure, right? This is how I can change or morph the infrastructure to make it better suit my application, right? And that's really what we are after, bridging that gap between, the developers and the operators.
So the operators get their infrastructure working well, and then your app will in fact monitor the message bus,
Right.
see whatever's going on in really quick time,
Yep.
and can spin up another 20 containers, and that can all happen in under a second,
Yes.
without any involvement.
Yes.
Okay.
Yeah. So it's, I think we're trying to take a big bite, but that's really what we are after, right? Helping them bridge that gap. Both those communities bridge that gap.